Hi gang, let's do more review for test 3. So let's look at simplifying a higher radical expression that's multivariate. Okay, so we'll try something similar to what will be on the test, and then I've added another one for you. Okay, so this is a 4th degree. So for a coefficient, it means that you need to have a number repeating 4 times. Now, for a number to repeat 4 times, that means it's going to get quite large fast, right? So let's think about what a 2, if a 2 repeats 4 times, right? If you have 2 times 2, we're already at 4, times 2 is 8, times 2 is 16. Okay, so a 2, 4 times is 16. If you do it 5 times, you're already at 32, right? It's going to fly up fast. So if you look at the 48, 48 is 16 times 3. So there is a perfect fourth in 48. It's 16 times 3, okay? So when you're looking for a perfect fourth in terms of a coefficient, it means that it needs to have a number multiplied times itself 4 times, okay? So 2 4 times is 16. So therefore, this 4th root of 16 will be 2. Okay, so I have to break 48 into the perfect fourth that's in it. So the perfect fourth in 48 is 16. Now, in terms of the exponents, it's going to be a perfect fourth if it's evenly divisible by 4. Now, we know that 16 divides by 4 evenly. So s to the 16th is actually a perfect fourth. So I don't have to modify it. But t to the 10th, if I divide it by 4, it doesn't go in evenly. Okay, so you need to have a number that divides by 4. So if you start with 10, 10 is not divisible by 4. That doesn't work. If you pull off 1, you're at 9. 9 is not divisible by 4. It's not until you get to 8 that 8 is divisible by 4. Okay, so you have to keep coming down in the exponents until you get something that's evenly divisible by 4. So now let me come back over here. So I need to write it as 10 to the 8 because 8 is divisible by 4, but I started with 10, so I need to make sure I have 10 down here in the radicand. So I'm going to give it the 2 that I pulled off. So I'm going to pull off 2 from the 10 to make it an 8, but altogether this still goes back to 10. Okay, I just have to break it into the perfect and non-perfect part. All right, let's go ahead and do the square root. So the 4th root. So the 4th root is 16. That's going to come out as a 2, big 2. 3 stays under. S to the 16. So exponents, remember, you divide. So 16 divided by 4 is 4. So that's s to the 4. So that comes out as s to the 4. T to the 8, you do 8 divided by 4 is 2. So that's t to the 2. So that came out, and then this t cannot come out. So the leftover in the radical is going to be the 4th root of 3t squared. Okay? And that'll be the final answer. So you take out the perfect parts. The parts that are non-perfect will stay under. All right, let me circle that one for us. Okay, let's try another. If you want, I would suggest you go ahead and just pause the video and try it yourself, and then we'll check answers. So why don't you go ahead and pause the video. Okay, so hopefully now you've tried it. And let's do this one. So fifth, you have to find the perfect fifths. Now 32 is already a perfect fifth, right? We had 4 2s up here. If you have 5 2s, five 2s make a 32. So therefore, 2 to the 5th is 32, or the 5th root of 32, 5 under, 1 out, right, would give you 2. So this is already a perfect fifth. Now for exponents to be a perfect fifth, it means that they have to be evenly divisible by 5. Okay, so now 12 is not evenly divisible by 5. So we have to pull off some x values. So x is not divisible by, 12 is not divisible by 5. If you pull one off, 11 is not divisible by 5. It's not till you get till 10 that 10 is divisible by 5. So you're going to break this You need an x to the 10. Now it's got to add back to 12, so that means that we had to pull 2 off. Okay, so this adds back to your 12, but now you've taken out the perfect fifth part. All right, y to the 15. 15 is divisible by 5, so that's already perfect. All right, now 18 is not divisible by 5, so we've got to pull some off of there, right? So 18 isn't divisible by 5, neither is 17, neither is 16. It's not till you get till 15. So I need to make this z to the 15. And for it to add back up to 18, how many more do I need? Good, I'm going to need 3 more because this would add back up to 18. 15 plus 3 is 18. So now I've broken it into the perfect and non-perfect fifths. So let's go ahead and do the fifth root now. So the fifth root of 32, that comes out as a big 2. 10 divided by 5 is 2, so that's x to the 2. This stays under. 15 divided by 5 is 3, so that's y to the 3. That came out. And then we have another 15, so 15 divided by 5 is 3. So that comes out, and then this guy's left under. So the one's left under is the x squared and the z to the 3rd. And try to remember to put the little 5 here. Sometimes we forget to do that. You don't want to forget to do that because otherwise we'll assume it's a square root, which it is not. Okay, gang, I hope that little review of higher radical expressions helped you. Catch you in another video. Bye-bye.